This section is on literal equations. Basically, these are formulas that are solved for a particular variable, and there might be situations where the variable we want to solve for, the unknown one, is on the other side of the equation. And so rather than plugging all these values in and having to solve these equations over and over and over again, if we could solve the original equation, the formula, then it would be easier for plugging these numbers in. Let's look at an example. Example might be the area of a rectangle was its length times its width. So suppose we had several of these where we knew the area and we knew the length. We wanted to find the width. We would keep plugging the area and length in and then solving the equation and finding the width. But it would be easier if we go ahead and solve for the width now, and then to find the solutions to all those ones we have to plug in would be very simple. So let's solve this for W. In other words, we want W to be alone. So how are we going to get W alone? Well, we're going to treat the A and the L just like they were numbers. So we're going to solve this the same way we solved the ones that had numbers in them. We have L multiplied by W, so in order to get W alone, we would have to get rid of the L by dividing. If we divide on the right side of the equation, we have to divide on the left side of the equation. The L's will cancel because that's 1, and 1 times W is 1. So it would be the same as W is A over L, or I could write it with the W on the left now. And now I could put in several values for A and L and just divide and get the W very quickly. So my answer to this is actually an equation. W equals A over L. Let's do one that's a little more complicated. Let's do P equals 2L plus 2W. And let's solve this one for W. Okay, remember when we're solving equations that we like to get the term that has the variable we're looking for by itself. In this case, the term we're trying to get alone is the 2W, because that's the one that has the variable we're solving for. So we want to get rid of the 2L term. So to get rid of the 2L term, it's added, so I'm going to subtract it from both sides. On this side it becomes nothing. What about on the left? Well, P and 2L are not like terms. Remember, we cannot combine terms unless they're like terms, so all we can do is write them next to each other. P minus 2L equals 2W. Now I want to get W by itself. The 2 is multiplied by the W. So I have to divide both the left and the right by W. 2 divided by 2 is 1. So that leaves me W on that side, and minus 2L over 2 on this side. Now can I reduce these 2's? The answer is no, because remember, order of operations, whenever I have a fraction, to treat it as if there is a parenthesis around the entire numerator. If I wanted to write it in the other direction, I would write W equals P minus 2L over 2. Again, my answer is an equation. Okay, let's try this one. Maybe I'll let you try this one. 3x plus 2y equals 6. And let's solve this for y. You go ahead and pause this and see if you can solve it, and then when you think you have it, turn it back on and make sure you did it correctly. Okay, so we're going to solve for y. So we want to get the y term alone. So we need to get rid of the 3x term. So I'm going to subtract it from both sides. Remember, when I refer to both sides, I'm always referring to the equal sign. So we want to keep this equal sign lined up. 3x minus 3x is nothing. So 2y equals 6 minus 3x. Remember, I cannot combine those because they are not like terms. I could, if I wanted, put the negative 3x first. Okay, now to get the y alone, I'm going to divide both sides by 2. So that's going to give me y equals 6 minus 3x over 2. If you would put the negative 3x first, you would have y equals negative 3x plus 6 over 2. Doesn't matter, each is the same. Okay, let's try this one. Y equals mx plus b, and let's solve this one for m. So I want to get m alone. How am I going to get m alone? I want to get the term with m alone by itself first, alone first. So I'm going to get rid of the b by subtracting it from both sides of the equal sign. On the left, they're not like terms, so all I can do is write them together. On the right side, I have mx plus nothing, which of course is just mx. Now I'm still trying to get the m alone, so I'm going to divide both sides by the x. Notice it's on the right side, that's okay. M times 1 is still m, so my answer is m equals y minus b over x. Okay, let's make our last one with a fraction. So x equals 2a minus b over y. And let's solve for a. First of all, I have a fraction. Really, on the left I have a fraction too. It's x over 1. But I don't need to think about that. The common denominator is y. So I'm going to multiply both sides by y. Recall, there are the invisible parentheses here. So that entire thing is being multiplied by y. So on the left, I have x times y, and I don't have to write the dot. On the right, notice this y and this y can be divided or canceled because they're y over y, or 1. So on the left, I'm left with, on the right side, I'm left with 2a minus b. On the left I have x times y, on the right I have 2a minus b. I'm trying to get the 2a term by itself, so I'm going to add b to both sides. So I end up with xy, or x times y, plus b, plus 2a plus nothing, which of course is just 2a. Still trying to get a alone, so I have to divide by 2 on both sides, and 2 divided by 2 is 1, so my answer is going to be a equals x times y plus b over 2. And that is my answer, an equation.